All right, CNT140, we are working on Chapter 5 on fiber optic. Here's some of the goals for the chapter. We're going to get a really good overview on this chapter of fiber. It's going to give us a lot more detail than we need at this point, but we're going to use this good overview. Later this semester, we're going to spend more time on fiber, so we'll fill in the gaps at that point. So we're just going to try to keep in mind that this is going to give us an overview, good overview. All right, so first thing, fiber optics and premise cabling. We know UTP copper has dominated premise cabling. The majority of our cabling in a building going from closets out to workstation is copper. Fiber has become more popular as bandwidth needs have grown. There is more use in industrial and corporate networks using fiber optic, especially for backbones, but we're also starting to see it being adopted for fiber to the desktop, centralized fiber or fiber to the desktop. So the book reminds us of our typical cabled structure here, fiber between closets, and from the closet out to the workstations, typically copper cabling, out to workstations, out to access points, etc. Centralized fiber, coming from our closet, we can run fiber out to basically a patch panel, and then run fiber out to a little switch at the desk for the workstation that's there or any devices that happen to be there. Can even run fiber out to access points. Fiber ports on access points are becoming more common. I put this in as a reminder of our typical structure. We have typically copper cabling going from closet, patch panel out to work area outlets, workstations, and then between closets, fiber optic, between our switches, fiber optic. So in many of our networks, our backbones are typically fiber. The connections between closets, connection between switches is typically fiber optic. Reasons being, we get a lot more bandwidth and longer distances with fiber optic. Fiber optics is unaffected by any interference, electromagnetic interference. So in industrial environments where you have a lot of motors, a lot of conveyor belts kicking on and off, robotic arms moving things, all that magnetic fields around all those, if I'm using fiber optic, the fiber optic is totally unaffected by those magnetic fields. So sometimes in industrial environments, you're using fiber optic simply for that reason. Fiber optic is smaller and lighter than UTP. You can usually get a lot more fiber cables in a conduit than you can copper cabling. And in some cases, a properly designed centralized fiber optic network may save money over copper because you don't need the extra data closets, you don't need the extra power in there, you don't need the extra cooling in there, that sort of thing in the closets. In some cases you can even skip them or use very minimal or small closets. So sometimes that savings kind of recoups the cost of putting the fiber in. Again, reminder on our backbones here between our closets. Reminder of our backbones between our closets. Again, typically fiber for those reasons we mentioned. Centralized fiber to the desktop. This can be, in some cases, a cost-effective solution, or a cost-effective solution could be fiber to the centralized fiber or fiber to the desktop. Fiber supports longer links. Again, I don't need those intermediate closets, those closets, data closets on a floor. Because of that, we save a lot of floor space, cooling space, power, UPS, all those kind of things that can add up over the course of a year. So again, they're reminding us of this structure here, from our main closet out to, it could literally be just a small little cabinet in the corner of a room that we have a patch panel in, fiber patch panel, that I'm splitting that fiber out to a workstation where we put in a small optical switch, if you will, or out to an access point where some access points actually have a fiber optic port on. I would just need to worry about getting power to it. I could do power over Ethernet out to it, but use the data through the fiber cable. With fiber to the home, using the passive optical network, a lot of that is now being adopted for use in buildings. So if you think about an apartment building, I think we had the picture down here of this kind of thing where you're going out and doing connection, different floors, different apartments, different rooms in a building. That technology is being kind of like converted over to large companies, large campuses, large buildings with a large number of users. That same kind of technology of fiber to the home can be used as your fiber optic network, your fiber to the desktop, if you will. So when your passive optical lands, using the fiber to the home, they typically call it fiber to the office. That's they'll name for use for that. Or they'll use OLANs, optical LANs, if you will. So using that, we can have the fiber optic coming from the closet out to a small mini switch at the user outlet. So you literally can have fiber wholly from the main closet out to a patch panel, and then fiber from there out to a mini switch at the workstation, and accomplish the same thing but with more bandwidth to the user and potentially less cabling upgrades over time. So they're showing this structure here, your main closet, fiber out to potentially a splitter. This might be a passive patch panel, but you can split out 24 fibers into, you know, a 24 bundle fiber into 24 individual fibers. I'll get it yet. And then those individual fibers can be going out to the little switch or little optical network unit at a workstation. And I put a couple of those here to give you an idea. This would be for like a single connection to desk, fiber cable into that green port, copper cable here to plug into the workstation. Here is actually a 2-port, fiber into this side over here, 2-port here. So you might be able to service 2 desktops there, or desktop and maybe an access point, desktop and a phone, things like that, giving you some options. So that structure, if I go back here, I can run this fiber optic cable from the main closet out to patch panel, split it out, go to the desk, and I put in one of these little switches here to handle that workstation there. Fiber the whole way to the desk, and basically a patch cable from the computer into here. So in this case, it can be a ideal solution for areas where you have large distance you need to cover, large buildings. Here, convention centers, libraries, airports, that sort of thing, where you have maybe large distances. This can scale easily to large networks. I'm using less space compared to traditional cabling because you don't need the telecommunication rooms. And again, your entrance facility electronics are smaller. I don't have as much to deal with. So this can handle large amounts of data, then high data usage. Another avenue is security. With this, you need to encrypt your traffic, but tapping into fiber is a lot harder to do than copper. So it's kind of like another step up in security as well. Some other uses for fiber, other premise uses for fiber. Again, copper has proven a valid choice, but and a lot of your building management systems using copper, thermostat, wiring, speakers, paging, that sort of stuff. Security still depends a lot on copper, but there are some things like security cameras and so forth that are starting to migrate to fiber for a little bit more security. Surveillance systems, coax was always the thing. There's the predominant cabling used for that. Some things have been migrating to your Cat5, Cat6 cabling, but some more systems are starting to use fiber for their video, surveillance cameras, video, that sort of thing. This adds a little bit of flexibility because you have greater distance with the fiber. I can put my cameras maybe in farther reaching locations or more applicable locations than we could with copper previously. And again, a lot smaller cabling to deal with to those locations. They remind us about a distributed antenna system. We talk about that a little bit later in the chapter. I have some more pictures and examples there. But if we look at statistics, a lot of our cell phone calls are originated inside of a building. So in some buildings, especially large buildings, sports arenas, football stadiums, hockey arenas, those sorts of things, convention centers, those kind of places, what they will actually do is use fiber optic to bring in a cellular antenna connection, if you will, to the users inside that can pick that signal up and carry it out. Instead of trying to make its way through large spaces or through walls and that sort of thing. So we'll talk a little bit more about that later, and I have some examples to show you later on that. But that's another use for. We said earlier about industrial networks, manufacturing plants, that sort of thing. Fiber optic tends to get used a little bit more, mainly because the noise immunity from all the machinery, electrical motors and conveyor belts and robotic arms, moving and energizing, they're producing magnetic fields. If I use fiber optic to this equipment, those cables are immune from all those magnetic fields. Not to mention I can have longer distances out to maybe a fiber optic, a robotic arm on an assembly line. I have a longer run, I can do that out to that robotic arm, if you will. Data centers, we talked about this in a previous chapter. Data centers are starting to use a lot more fiber optic for that high bandwidth connection between racks of servers, switches and racks of servers that would be in there. And again, over the time, less upgrades are needed. And I pulled this picture back from, or out from another previous chapter where we talked about data centers, just reminding you of like fiber patch panels, fiber switches that would be used to connect directly to the servers. All right, we'll come back in the next podcast. We'll start digging into some specifics about fiber optic cabling.